In this video I'm going to explain to you what we mean when we talk about prime numbers. It follows pretty much directly from a video where I talk about factors and multiples, which is something you must be fairly solid about before you can understand this. So if you're not too sure about factors and multiples, it should be the first video down here. The next one should be one about prime factors. So if you want that, by all means listen to this one, but the prime factors one is the second one on the list. Now, in the video about factors, I used 24 as an example, and I use my blobs here to talk about how we can find the factors of 24, which of course is all the numbers that go into it. If I do the similar thing with 18, this is 18, firstly, I'm going to make this into a rectangle just to show that 18 isn't a prime number because it does have factors. So let me just do that. Remarkable turn of speed. Okay, so what we've got there is 6 times 3. 6 times 3 is 18. That proves that it's not a prime number, it has factors. To produce a prime number, we'll try some different numbers. Maybe if I add another blob to this one, is there anything I can do to rearrange these to make a rectangle with that extra blob? Maybe I can make an extra row or one row fewer or something. Well, I'm telling you now, no matter how long I spend trying to rearrange these, I will not be able to make a rectangle out of this number. Because 19 is what we call a prime number. It doesn't divide by anything. Nothing fits into it exactly. So the only way I can make a rectangle out of 19 is by having all of them lined up in a row, one underneath the other. And of course, technically speaking, every number has itself and 1 as a factor. It's too big. So every number has itself and 1 as a factor. So this number, we can't say that that has factors apart from itself and 1. This is the number 19. It is a prime number. I could take that one off back to 18. I could say 17. Again, I can spend as long as I like trying to arrange 17 blobs into a rectangle. It's not going to happen. 17 doesn't have any factors. 17 is a prime number. We can't divide it by anything exactly. Now, I'm just going to mention one or two other things. So I'll reveal my little table of numbers here again. We can do some things on here to find out what the prime numbers are, because understanding what a prime number actually is the first thing, but quite often we need to use the prime numbers in other calculations, particularly when we're doing prime factors and that kind of thing, and there's a lot of useful stuff we can do with that. So we need to know how we can actually find out some prime numbers. Here are the numbers 1 to 120. We can very quickly find out which of these are prime numbers. Now remember, we've got to work out which numbers do not have any factors. So if we find out which numbers do have factors and see what's left, that would obviously do it for us. As it happens, there was an ancient Greek mathematician called Eratosthenes, around about 2,000 years ago, who did some very famous work on this. He also, incidentally, calculated the size of the Earth very accurately by shining sun down wells and stuff like that. Very, very clever bloke. What we're concerned with is his work on prime numbers, and there's a method called the Sieve of Eratosthenes, which will very quickly find out these prime numbers. And he worked out that if you start to remove all the multiples of numbers from this table, you will be left with just prime numbers. Now, the first thing, the number 1 cannot be considered as a prime number. If we consider number 1 as a prime number, then everything would have factors, because 1 and itself is a factor of everything. So you can't have number 1 as a prime number. Okay, so that one, we've got to cross that one out before we even start. Right, so I've crossed out 1. Yeah, slightly bolder line, I think, than that. No, I'll cross out 1. Now, 2 is a prime number. It has no factors apart from 1 times 2. So that makes it a prime number. So I'm going to start listing the prime numbers up here. I'll put prime numbers 2. That's the first prime number. So what we then do is we remove from the table all the numbers which are multiples of 2, because they can't be prime numbers, because they have 2 as a factor. Now that's an important one, because that means all the even numbers have to disappear, because all the even numbers have 2 as a factor. So therefore we can immediately remove everything in this column, everything in this column, this column, this column, this column. So that's half of our numbers gone before we even start to look at anything else. So that's the first thing. Then we think 3. Is there anything that goes into 3, let me cross out 2, anything that goes into 3 apart from 3 and 1? No, there isn't. Therefore 3 is a prime number. So I'll put 3 up here. So then, of course, what we've got to do, remember the next step, is remove from this table all the multiples of 3. So 6 has already gone, 9. 12 has already gone, 15, 18, 21. As it happens, and this will speed up my crossing out the table, the multiples of 3 are in diagonal lines. So I can draw diagonal lines through the table. So if I draw a diagonal line from 3 there, 6 here, 9, that's those ones. What's the next one? 12, 15? Well, we just add diagonal lines every third number. So 39 is one, so 30 is one there, so we go this way. Then there's one here. There. One here. Okay. Have I missed any of those? No, I think that's it. Okay, so 3. Then we look. 4, no, 5. Is there anything that goes into 5 apart from 5 and 1? 1, 5 is 5. Nothing else. So 5 then is our next prime number. Okay, so we can then remove all the multiples of 5. As we know, because it's quite obvious, that is simply this column here and this column over here. Now this column over here has already been removed because they were even numbers, multiples of 2. So all I've got to do for 5 is cross out all the numbers in that column there. So that's quite a quick job. Okay, so let's get rid of all those. Then I look, 6 is not a prime number. 7. Do any of these things go into 7? No, they don't. So 7 is also a prime number. Now I've got to remove all the multiples of 7. Now there's something a little bit clever I'm going to mention. The only multiple of 7 that I need to worry about is the ones which are bigger than 7 times 7. Or 7 times 7 and upwards. Because if we think about it, 7 times 6, or times 5, times 4, times 3, times 2, times 1 would already have been removed, won't they? Because I've done all the multiples up to 7. So it's only 7 times 7 and upwards, which is 7 squared and upwards, that I need to worry about. 7 squared is 49. So I look at 49, and from there, after that, I remove all the multiples of 7. Where it's useful to know your times tables, it's always useful to know your times tables. So I get rid of 49. 7 sevens are 49. 8 sevens are 56. Then we've got 63, that's gone. 70, that's gone. 77, that's still there. Okay. 84, that one's gone. Where have I got to now? 91. Then we've got 98. Then I've got 105. Then I've got 112. Then I've got 119. Right. Those are all my multiples of 7. Then is 8 a prime number? No, it's not. Is 9 a prime number? No, it's not. Is 10? No, it's not. 11. Does 11 have any factors up here? No, it doesn't. So 11 is our next one. Believe it or not, we're coming to the end. I know we've only got along the first row, but this quickly resolves itself, you'll find. Because 11, okay, 11 is indeed a prime number. Now, what we said earlier is that we only need to concern ourselves now with numbers that are bigger than 11 times 11, because we've already done everything else. 11 times 11 is 121. 121 is beyond the end of my table. So actually, I've done it. Eratosthenes and I, we've done it. There's nothing else to cross out. So any numbers now remaining, which have not got the green chalk through, will be prime numbers. So we can just add them to the list up here, and we've basically done it. So where did we get to? So, all being well, if we've done that correctly, or if I've done that correctly, these are the prime numbers between, well, up to 120. And remember, these are numbers that have no factors. So if you try dividing these numbers by any smaller number, you should find nothing fits into it exactly. You'll get remainders, you'll get a decimal point. From this point, you might want to consider some of the other videos about prime factors and the things that those are used for, specifically highest common factor and lowest common multiple calculations, which follow on and can be found on the website up there, probably links in the description underneath.